Welcome back to the next lecture of breathing and exchange of gases. Now in this class we are going to deal with the next heading, which is called as exchange of gases. How exactly the exchange of gases occurs and where exactly the exchange of gases occurs. So exchange of gases occurs in the lungs, in between the alveoli and the blood vessels. Exchange of gases occurs in between the blood and the body cells or the body tissues. So this is how the exact method of exchange of gases will occur. So with this, let's look at the diagrammatic representation of alveoli and the blood vessel, which are the membranes that are involved in exchange of gases in the lungs. Okay. Now let us come to the structure. Now suppose if you cannot see the PowerPoint here properly, I will draw the diagrams, and most importantly, anyhow it is given in the text also. You can refer the text and listen to the video properly. So that's why if visibility is less, your audibility should be more. Okay. Now regarding exchange of gases, in the diagram we can easily see the alveolus, and as we know, we have numerous alveolus in the lungs. These alveoli are involved in exchange of gases. That means transport of O2 and transport of CO2. Okay. Now suppose if we look at the alveolar membrane, if this is the alveoli is lined by a thin membrane. This membrane is called as a squamous epithelium. Then this side we have the blood vessel. This is the blood vessel. We call it as blood capillary, which comes to the lungs. That brings the deoxygenated blood. Okay. Now this is the alveoli. Now here air will enter. Air common term. That may be oxygen or it might be carbon dioxide. So oxygen will enter, carbon dioxide will leave. That means air will enter into the alveoli. Now this is the alveoli. This is a squamous epithelium. Then here we have, these are the endothelial cells. And in between these two, here we have the basement substance. Look at this. Now we have squamous epithelium, basement membrane, and an endothelial layer of blood capillaries. All these three together. So this is a 1, 2, and 3. All these three together, if we look at their thickness is less. Okay, its thickness is less. We say less than 1 millimeter. So what is the thickness? The thickness of this is less than 1 millimeter, or we also say it as it is around 0.5 micrometer in its thickness. Okay, so this is the most important, which is given in your NCERT. The thickness is less than 1 millimeter. Okay, so this is regarding the thickness of the alveoli and the blood vessels, along with the basement substance which is present in between the alveolus as well as the blood vessel. So all these three together forms a thin membrane. It helps in diffusion of gases, exchange of gases. Now here blood will come, and from here the blood will leave, and as the thickness is very less than 1 millimeter, 1 mm, or we call it as it is around 0.5 micrometer in its thickness, which helps in diffusion of gases. Okay, so this is how the exchange of gases occurs at the alveolar level. Okay. Now with this, let's move on to a chart. That chart will show regarding the atmospheric oxygen and carbon dioxide level, then alveolar O2 and CO2 level, oxygenated blood O2 and CO2 level, deoxygenated blood O2 and CO2 level, and tissue O2 and CO2 level. So we have a chart for this, and with respect to this chart, next we will go to the transport of gases. Okay, now let's go to the chart of the gases. Okay, now in the exchange of gases, if we look at this chart, in this chart we can make out the respiratory gases. Now here we have the chart called as a respiratory gas. Now in this respiratory gas, here we have PO2, PCO2 level. This is in mm of mercury. This is also in mm of mercury. Okay. Now here we have this chart. This chart will show what is the level of oxygen and carbon dioxide. This chart is most important because out of these any one will be asked. Okay, now first, as we come across a PO2 and PCO2, we come across a term called as a partial pressure of gases. Partial pressure of gases. The partial pressure of gases of oxygen is represented as a PO2, and that of carbon dioxide is represented with the PCO2. PO2 and PCO2, we call them as partial pressure of gases. Then what is this partial pressure? Partial pressure is nothing but the pressure exerted by an individual gas in a mixture of gases is called as partial pressure. The pressure exerted by an individual gas in a mixture of gases. Here we are taking two gases in the alveoli or in the atmosphere also, CO2 and O2. Okay, apart from this, even nitrogen is also there. Okay, so we'll discuss about this. Now, in the partial pressure of gases, PO2, PCO2, it is in millimeter of mercury. Now, here we have the atmospheric air. This is around 159 mm of Hg. O2 level and CO2 level is 0.3 mm of Hg. Then in the alveoli, this is 104 mm of Hg. CO2 is 40 mm of Hg. Then in the blood, which is deoxygenated, in the blood which is deoxygenated, this level is around 40 mm of Hg, and O2 is a little bit high, 45 mm of Hg. Then the blood which is present in oxygenated, the oxygenated blood consists of 95 mm of Hg of CO2 and 40 mm of Hg in case of CO2. O2 is 95. Then in the tissues, O2 is 40 and CO2 is 45 mm of Hg. So this is regarding the chart that shows a clear-cut difference in partial pressure of gases. Suppose if we look at the partial pressure of gases, in the partial pressure of gases, we have the O2 level as well as the CO2 level. The O2 level in the atmospheric air, the O2 level in the atmospheric air is around 159 mm of Hg. That of CO2 is 0.3 mm of Hg. Then in the alveoli, the O2 will be 104. So how we can make it easily? Okay, now here, suppose if this is the alveoli, and we have a diagrammatic representation of this in the NCERT also, and if we take a heart, now here we have the blood vessel that comes, and here we have the blood vessel that leaves the heart, and here we have the tissues, body cells. So these are the tissues. So this is the tissues, and here blood will enter, blood will leave here, blood goes in this way, blood comes to the heart. Okay. Now here we have PO2 and PCO2 level also. This is in the alveoli. This is the blood vessel. We call it as a pulmonary vein. Now this vein, it has a PO2 and a PCO2 level also. And in the tissues we have PO2 and PCO2 level also. In the deoxygenated blood, here we have PO2 and PCO2 level also. Okay. Now here we can easily make out. Now whatever we have written in the chart, we'll take this in this diagrammatic representation. Okay, what is this? Now PO2, partial pressure of oxygen in the atmospheric air, is 159 mm of Hg, and CO2, that means the oxygen that we take in and the carbon dioxide along with it, when it enters into our alveoli, its rate is a little bit high. Atmosphere is 159 and 0.3 respectively, and when it enters into the lungs, in the lungs PO2, its level will be around 104 mm of Hg, and PCO2, its level will be around 40 mm of Hg. That means the concentration of oxygen is more than carbon dioxide. Look at this, in the alveoli, as these are present in the form of mixture of gases, we call it as a partial pressure. That means the pressure exerted by an individual gas in the mixture of gases is said to be partial pressure. Okay. Now, what happens here? This is 104 and 40 mm. The oxygen that comes, the carbon dioxide that comes to the lungs, here we have PO2 and PCO2 level. Okay, now this is the deoxygenated blood. Look at the deoxygenated blood there. What is given in the chart? Deoxygenated is O2 is 40, that means it is low, and CO2 is very high, 45. So here PO2 is 40 mm, this is 45 mm of Hg. Okay, then when it comes here, carbon dioxide is released, oxygen is taken into the blood vessel, then ultimately the PO2 level will increase. This is the oxygenated blood that leaves the lungs. The blood vessel that comes to the lungs, it carries a deoxygenated blood, more CO2, less O2, and the blood vessel that leaves from the lungs, it carries a higher O2 and less CO2. That means here PO2 and PCO2 level on the oxygenated blood. Just here, this is 95 mm of Hg, PCO2 is 40 mm of Hg. Then it goes to the heart. You know the circulatory system also. When heart pumps, the blood has to be supplied to all the cells and tissues. And when it goes to the tissues, we have the same blood will go to the tissues, and in the tissues PO2 level is 40, PCO2 level is 45 mm of Hg. Look at these tissues. In these tissues, O2 level is less, CO2 level is high. As a result, there is an exchange of gases, diffusion process will occur, where we also call it as internal respiration. This is external respiration, this is internal respiration occurs. Then after that, from the tissue, the blood which comes carries a deoxygenated blood. That means a higher concentration of CO2 and low concentration of O2. And again the same blood will come to the lungs and diffusion of gases will occur. Okay, now this chart is most important. Now along with the O2 and CO2, these are given in your NCERT also, we have one more gas where we call it as the nitrogen. The nitrogen which is present in the atmospheric air, it is around 596 mm of Hg. It is around 596 mm of Hg. And this will enter into the lungs, and from the lungs it enters into the oxygenated blood, and in the oxygenated blood the amount or the mm of Hg of nitrogen is around 573 mm of Hg, and in the tissues there is no nitrogen. As nitrogen is inert, it does not react with any other. Now suppose if we are respiring nitrogen, it does not affect our lungs and it does not combine or react with any other gases. It goes and again it comes back to the lungs. Same thing only. This is about the specialty about the nitrogen gas that enters in the inhaled air. Now, suppose if we are inhaling a pure nitrogen, it is quite dangerous because it may damage the tissues and it may damage the oxygen binding capacity with that of the blood or hemoglobin. Okay, so that is the thing. So this is one additional. The nitrogen that enters along with oxygen and carbon dioxide in our lungs is around 596 mm of Hg. Okay, so this is regarding the part of exchange of gases. How exactly the gases gets exchanged. So with this, we'll move on to the next part. The next part of it will be the transport of gases, and we'll come across the major heading of it also. Okay, now in the transport of gases, we have transport of O2 and transport of CO2. Okay, the transport of gases, transport of O2 and transport of CO2. Now, oxygen is also transported, carbon dioxide is also transported. How exactly they are transported? So let's look at that part. Transport of gases. In the transport of gases, first one we have transport of oxygen, and in the second part we have transport of carbon dioxide. Okay, so transport of O2 and transport of carbon dioxide. Oxygen is transported in two forms, carbon dioxide is transported in three forms. Okay, so what are the forms of this transport? Transport of oxygen. Oxygen is transported majorly in two forms. One, 97% of O2 is transported by hemoglobin Hb in the form of oxyhemoglobin. 97% of oxygen is transported by the hemoglobin of the blood, and 3% of O2 is transported by blood plasma. Okay, so 97% of oxygen is transported in the form of oxyhemoglobin, 3% of the oxygen is transported through the plasma, again in the form of oxyhemoglobin only. This is by hemoglobin, this is by the plasma of blood. Now let us go to transport of CO2. CO2 is transported in majorly in three forms. What are those? The first form is as a carbonic acid. The second form is as a carbamino hemoglobin, and the third form is as bicarbonates. Then what is the percentage of this as carbonic acid? Now around 7% of the carbon dioxide is transported in the form of carbonic acid. Okay, now as far as this 7% is concerned, it is by the plasma. Okay, and as a carbamino hemoglobin, around 23 to 25% of carbon dioxide is transported by hemoglobin of RBCs. Hemoglobin of RBCs in the form of carbamide hemoglobin, and as bicarbonates it is around 70 major part 70% of CO2 is transported by RBCs. Okay, so this is how the gases are transported. Now look at this, how the transport and exchange of gases occurs. One, how oxygen is transported, how carbon dioxide is transported. Oxygen is transported from the lungs to the tissues through the blood. Then carbon dioxide is transported from the tissues to the lungs through the blood. Medium is same only, that means the blood has to carry the oxygen, simultaneously it has to bring the carbon dioxide towards the lung for the exchange of gases. So this is how the transport of gases occurs. So how exactly it occurs? Remember the first one and second one of transport of oxygen, and these are the three methods of transport of carbon dioxide. And these are most important because what is the percentage of oxygen transported by the blood, major part in the form of oxyhemoglobin. So 97% of the oxygen is transported by the hemoglobin of the blood, RBCs of the blood, in the form of oxyhemoglobin, and 3% is by plasma. This is most important. Then regarding carbon dioxide, 7%, only 7% is transported by the plasma of the blood. Then 23 to 25% is transferred by Hb of RBCs. Then 70% of CO2 is mainly transported by the RBCs in the form of what? It is in the form of bicarbonates. So major transport is in the form of bicarbonates. Okay. So regarding the detailed account of oxygen, because in the oxygen there is an elaborate expansion for this also, as we have the oxygen dissociation curve along with that Bohr's effect, Haldane effect. Okay, so that will continue in the next part. Thank you.